Alright guys, good morning. So today we're just going to go over square roots. So here's a quick introduction, okay? So a square root, okay, really quick, looks like this. That's a square root. And a number goes underneath it, right? And so here's the background between a square root. So if you notice this square, there's 1, 2, 3, 4, right? The side, the length is 4, and eraser. So you would do 4 times what? 4, right? Because this is 4 units as well. And so because you did 4 times 4, right? This is called your area, right? So the area, the square area is 4 times 4, which is 16. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16, right? So the square area, right, you notice the word square, is 4 times 4. Isn't this a side, right? Let's just call it a side. And isn't this a side? So the side times the side gives you your, what you would call, area, right? So look at what you got. Isn't this just 4 squared equals 16? So now it's the same thing as saying the side times the side, right, equals your area. Well, isn't that just s squared equals your area? So I'm going to flip it around. So the area of a square, right, is equal to s squared. Now, let's go backwards. How do we get the area of this square? How do we get that? Didn't we do a length times a length? A side times a side? So then, the square root undoes the area. So, for example, let's go down here. To find your area, right? I don't want to know the side, right? I don't want to know the total area. I want to know how much is each side. So remember, inverse operation. What's the opposite of addition? Isn't it subtraction? What's the opposite of multiplication? Isn't it division? So what's the opposite of squaring, right? Squaring. So that's like s times s. The opposite of squaring, right? It's an exponent. What's the opposite of squaring? Well, the opposite to undo it would be a square root. Okay, so the square root undoes, right? It's the inverse. It's the opposite of squaring. So these are opposites. So here we go. You're going to get this. So this diagram is in the shape of a square. This diagram contains how many squares? How much did we count? Didn't we count 16 squares? So then what's the total area? So if we counted, right, all these, what did we get? We got 16. So the total area, which would be 4 times a 4, is 16 squares. And what is the length of each side? Right? So what is the length of one side? Okay, well that would be 4. So it says using the formula, area equals s squared. S is the side length. So this would be something good to write, right? S is the side length. So here we go. The area, oh my gosh. The area was 16, wasn't it? And how did we get 16? Well, we got it from 4 times 4. And so 16 equals 4 squared. So what if I wanted to know just the side length? So if I told you that I had an area, right, total of 36 squares, right, 1, 2, 3, 4, 5, 6, 7, 8, 36 squares, what does this side have to be, and what does this side have to be? What times what is 36, right? And so you know that this has to be what? A 6 times 6. So S is 6, because 6 times 6 is 36. But you don't want to draw a picture every time. So here we go. A square root. What if I give you the square root of 4? Okay. What times what is 4? Right? So isn't that just 2 times 2? So isn't that the same thing as 2 squared? And look, guys, what's the opposite of a square and a square root? I mean, no, what's the opposite? What is the inverse operation of squaring? So that actually went away. These undid each other. So algebra, right, these undid each other, so it's gone. So here we go. The square root of 4 is 2. The square root of 9. Okay, so what does that square have to be? What is the side length, right? This is the side length right here. It had to be 3, right? This is 3 times 3 gives you 9. Okay, what is the square root of 16? Well, isn't it 4 times 4? So what is that side length? 4. So the square root of 25, do you notice a pattern? Right? What is the square root of 36? What times what? Right? Isn't that the same thing as 6 times 6? So then the side length will have to be 6. Square root of 49. Square root of 81. Right? Square root of 100. Well, it's not 10. It's, yeah, there you go. Square root of 121. And you can keep going, right? What is now 12 times 12? 144. Right? 169 or 13. So here we go. Look at the pattern. Do you notice that these are just multiplied, right? That's what gives you the inside. Okay, so keep that in mind as you're filling out your quiz and your iExcel. Now, the next thing that you're going to see on iExcel is, these are called perfect squares, by the way, okay? These are called perfect squares because the squares have to be perfect. That is not a perfect square, right? It would have to be a perfect square where they have the same amount of side length, right? So 4 and 4, that's a perfect square. And the side length, right, would be 4. So what if you don't have a perfect square? What if you have the square root of 11? That's not a perfect square. A side times a side will never give you 11. So now we have to estimate. Here's your second iExcel. Give me the two square roots that 11 fits in. Well, square root of 4? Nope, doesn't fit there. Square root of 9? No. Square root of, what's next, 16? So 11, where does it fit? Does it fit before 4 and 9? Or square, yeah, in there. Or does it fit in here? Right? Wouldn't it go here? So now, since it goes here, it's getting sloppy, guys. What did we say the square root of 9 was? Right? Isn't this just a 3? What is the square root of 16? Isn't that 4? And is 11 closer to 9 or closer to 16? Oh, it's closer to 9, right? So it'd be like square root 11 in there. So then your answer for square root 11 has to be really close to 3. So it'd be 3 let's estimate 2, or maybe 3.1. This is an estimation because it's not a perfect square. Okay, so these would be good answers. So now let's do it again. What you want to do is square root of 4. You need to know your square roots, right? Now with the square root of 1, just 1, right? 16, 25, right? 36. This is, right, 2 times 2, 3 times 3, 4 times 4. You see that? 5 times 5, 6 times 6. what's next? 7 times 7, so it's 49, right? So what do these square roots equal? Here we go again. That equals 1, that equals 2, that equals 3, that equals 4, that equals 5, 6, and 7. If I give you what is the square root of 28, where does that go? It can't go here because it goes 28 comes after 25. So it would be like right here, right? 28. So give me an estimation of the square root of 28. Well, it's really close to 25, not so close to 36, right? 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, right? 28 is closer to 25 than 36. So that means that, actually let me finish that. 34, 35, 36. Here we go. What is the square root of 36? 6. What is the square root of 25? 5. 28 is closer to 5 than 6. So the square root of 28 equals 5 point, I don't know what, 4, right? It's just an estimation. Okay? You could say 5 point, I don't know, 3, right? It's just an estimation, but it's definitely not close to 6, right? So sometimes it helps to see where it's closer. Alright, so go ahead and get your quiz is done. If you need to take notes on this, please take notes. Use your notes on your quiz is, and then which is also graded as a test. Okay, remember, test scores are 60% of your grade. So please make sure that you watch this again. It's a short video, and get your quiz is done. All right. Make sure you're staying on task when you're done with quizzes. So here's so you already watched the video. You're gonna do your quiz is link in Google Classroom. Then you're gonna do IXL F13, IXL F14, IXL F. I think you can keep going. 15. All right. There's your task.